This lecture will relate to the basics of solutions and how solutions form. This lecture will relate to solutions and the basics of how solutions form. Here are some of the key concepts that we'll be discussing. Some terms solute and solvent are going to be some identified vocabulary, and you'll need to be able to identify them from a given solution. Describing the dissolving process is what we will be going through. How does the solute dissolve in the solvent? Also, given two substances, you'll be asked to predict whether one compound will be soluble in another. And then finally, there's a special type of solute called an electrolyte, and you'll need to understand what that is and explaining how it works, and also determining whether a certain compound will be an electrolyte or not. So, first to solutions. A solution, by definition, is a mixture of two or more substances in a single phase. And what that means is that the appearance of the solution is all one phase. So you could take solid NaCl and mix it into liquid water as the solvent. Even though it's a solid within the water, it gets dissolved such that the overall appearance is liquid. So it's all going to look uniform. The two main parts to a solution, you've heard these words just in the last few moments. Solute, which is the substance being dissolved. And at a particle level, you may not know what dissolved means yet, but on a practical level, mixing something in, mixing sugar into a drink, say, is being dissolved. That would be the solute going into the solvent. The other way you know the solute is that it's the smaller amount. If you're given two amounts, the solute is the smaller one. The second part is the solvent, which is the substance doing the dissolving, and we'll explain what that means. But another more basic way is that it's the larger amount. So the solvent is present in a larger quantity. So as quick practice, let's identify what's the solute and the solvent in each of these examples. So, salt water. Think about that for a moment. You might want to pause this, write it down. But the solute would be salt. The solvent would be water. Sugar water, same idea. Sugar is the solute because it's the lesser quantity. Water is the solvent. Water's the most common solvent that we'll be dealing with in this class. How about this? 14 karat gold. These are the rough percentages of the metals. Now, we're used to solutions being thought of as liquid, but you can have a solid solution because it's all one phase. They're all mixed in together. In this case, the solute could really be any of those other lesser quantities. Could be zinc, copper, silver. Gold would be the solvent. That's what, in a way, dissolves the others. It surrounds all of those other elements. Next is this concept of solubility, which to be soluble is the ability to dissolve. So to be soluble is the ability to make a solution. For example, salt is soluble in water. Oil is insoluble in water. If you've ever tried to put oil in water, it is insoluble. Certain solids are insoluble. Calcium carbonate, for example, is an ionic compound. It doesn't dissolve in water. So you can put calcium carbonate in and it doesn't dissolve, which is good because most calcium carbonate is, well, most eggshells are made of calcium carbonate. So if you had, say, a fish egg or a turtle egg, if it's made of calcium carbonate, you don't want it to dissolve in the water because you need that thing to develop. Looking at the solvation process, also known as the dissolving process, also known as the solution forming process. You have in the middle there sodium chloride. So you have the gray ones with the plus sign, those are sodiums. The negative with the larger green ones are the chlorines. And then the red with white, that is your water, H2O. Notice that what happens here, the solvent particle, being the water, is attracted to certain solute particles. Notice that the positive part of the water, the hydrogen end, is what's orienting itself towards the chlorine. The negative oxygen, because that's where the more electronegativity is attracted to the positive sodium, and they're kind of like plucking them off. So these attractions are disrupting the attraction of, say, this chlorine to the other sodiums around it. So it disrupts it and kind of captures it in a way and takes it away. That's the dissolving process. The solvent surrounds solute particles and then kind of carts them off. And then once the solution is made, they're all just kind of mixed in there together, making attractions, losing attractions. It's sort of this, in a way, kind of free-for-all where positive, negative attractions are made and then broken and made and then broken, and they're all, in a way, mixed up. So after you have solvations, okay, solvation is where you're plucking them off. This is what you end up with. So this is really a solution now, where you have the positive, the partial positive partial positive hydrogen attracted to the negative chlorine. Notice how all the waters are oriented in. And then you get this solution set up. What's missing from this image, and just to not overcomplicate things, is that what's missing is the sodium. So you can maybe see in all those blank spots there would also be a sodium 1+ that would be attracted to the negative ends of the water that are sort of sticking out. So that's a solution. It's sort of this mixed up matrix, but you do want to remember from kinetic molecular theory, these are all moving around. They're not just stuck in place. So even though this looks kind of permanent and they're all sort of partnered up or grouped up, those groups are not permanent and they move from one to another. But that's the general idea. Next, in solution formation, solutions don't form just because. They need to have an attraction there. So the solution will only form if there is solute attracted to solvent and vice versa. If there's not attracted, for whatever reason, it's called insoluble. So those are two terms. Soluble means they will dissolve. Insoluble means they will not. They're not soluble in each other. Here's your general rule of thumb. A rule of thumb, it's kind of like a guideline. It's not a firm rule. It's not a rule that is 100% true all the time, but it's a guideline. It's true most of the time, which is two polar molecules will dissolve in each other. So like water and vinegar, polar. They'll dissolve in each other. Water and salt, those are polar. That'll make a solution. If you have a polar molecule paired with another non-polar substance, it will not dissolve. So water being polar, oil being non-polar, will not dissolve. Likewise, like dissolves like, two non-polar substances will dissolve in each other. There's a special type of solute, and it's called an electrolyte. And an electrolyte implies electricity maybe, and that's exactly what happens. An electrolyte is one where if you take that substance, if you dissolve it in water and make a solution, it will conduct electricity. And how does it conduct electricity? Well, you've got these two electrodes, and they're separated. Now, this is connected to a light bulb. So if you can follow the cursor here once it shows up again, if you can get current flowing from here across, if you can connect that with negative or positive charges, you then have a complete circuit. And when you have a complete circuit, the light bulb lights up. So we'd have ions flowing from one, say, to another. If there's no ions flowing between them, you don't have an electrolyte. It wouldn't light up. So electrolytes are generally any ionic substance. There's probably some exceptions to that, but as another rule of thumb, any ionic substance dissolves to be an electrolyte. Sodium chloride, HCl, and so on. HCl is not strictly speaking an ionic compound, but it does dissolve to form ions. So that's another good example. Acids tend to be electrolytes because they dissolve to form ions. A non-electrolyte is a substance that doesn't form ions. So when it dissolves, it forms molecules and do not conduct electricity. So here's your general piece to look for. Determining is it an electrolyte or not. First, look at the chemical formula. Is it ionic or molecular? If it's ionic, electrolyte. If it's non-ionic, or if it's a covalent molecule, it's a non-electrolyte. So NaCl dissolves into ions, that's an electrolyte. Calcium chloride dissolves, that's an electrolyte. NO2, nitrogen dioxide, that's a molecule, it's not ionic, it's a non-electrolyte. Another way to tell if it's an electrolyte is if it dissolves and actually conducts electricity. So you can actually do this as a test. You can put these in, you can take the substance, you could dissolve it and test it with that setup like you saw on the previous slide. If it conducts electricity, then you're good to go. And it is an electrolyte. This is kind of a little schematic here of electrolytes in action, going from where the ions, once they dissolve, they kind of move and will be sort of attracted from one to another, and they're carrying the charge. So this is dropping positive ions in. This has a negative charge here, and so whenever you get some sort of movement going from one to another, you have a completed circuit. So that's what it looks like, even though it's kind of a silly picture there. So, determine whether some different common household items are electrolytes. So here's a little practice for you. Tap water, deionized water, H2O, salt water, NaCl, or sugar water. So think about each of those. Try to determine which of those would be considered an electrolyte. I'm actually not going to reveal the answers within this lecture. We're going to be going over these in class in demonstration. But we will, what you want to look at is, are these ionic or not? So here's our recap of this lecture about solutions. We have two parts to a solution, solutes and solvents, and those dissolve to make a solution. The dissolving process itself is where solvent particles surround solutes particles and are attracted to them and kind of carry them off and surround them in such a way that the solute particles get separated from each other until ultimately you can't actually see them anymore. They're all mixed up within the solvent. Finally, you have this special type of solute called electrolytes that when they dissolve would conduct electricity. They have a big function in our body as well, carrying charge across cellular membranes. We'll be looking at some examples in class. And the big key there is ions. Is it an ionic compound or not? And that's it for solutions in this particular lecture.